to talk a little bit about a production possibilities frontier in this video. So remember, the production possibilities frontier, or PPF for short, is an example of an economic model. A model is just a simplified way of representing something, some kind of phenomenon that we would see, in this case in an economy. So here we're looking at the society or economy of Omnivoria, and our simplification here is we're going to assume that Omnivoria can produce just two goods. And let's get a marker that's going to write a little bit better. In this case, my two goods are salads and burgers. Now, in a real-life economy, obviously, a lot more than two products can be produced. But in order to make it easier to graph, we're going to restrict our model to just two goods. The second assumption that we see in a production possibilities frontier is we're going to fix or keep stable or constant a couple important factors in producing. So we're going to assume that there are fixed resources. So these are things like natural resources, land, labor, capital, and the other concept that we're going to fix here is the level of technology. So we might think about that as equipment, techniques, know-how, innovation. We're going to assume those are fixed. Okay, so here's my summary of some combinations of salads and burgers that can be produced in Omnivoria. So what I've done is I've listed 6 combinations and I've labeled them A, B, C, D, E, and F. And we're going to plot those on this graph in just a moment, and that is going to show us our production possibilities frontier. But I want you to notice a couple of things here. First, that we have on the salad column increasing levels of production. On the burger column, decreasing levels of production. This illustrates the trade-off that Omnivoria faces. Because it has fixed resources, meaning the inputs it needs or requires to produce salads and burgers, as it produces more of one, it necessarily has to give up or sacrifice producing some of the other good. The other thing I want you to notice when we look at these numbers, and this will become clearer when we graph these combinations, is I've purposely changed the level of production of burgers by the same amount, 100 burgers, for each of these combinations. However, that doesn't correspond to a constant or the same change in the number of salads. And we'll talk about that after we show this on the graph, but that's just going to illustrate this concept of rising opportunity cost. Okay, so why don't we go ahead and graph these combination points to get a sense of what our PPF looks like. So I'm just going to work my way down. Actually, I'm going to start with my first point here, point A. And I personally find in graphing, if I have endpoints or extremes, I like to start with those. So I'm going to look at my point A, and let me back up and just say, I've already drawn my graph or set it up. Ideally, you want to use graph paper because this will help you keep your scale consistent. But on my y-axis, I'm going to plot the number of burgers. So I'm just going to label that here. And on my x-axis, I'm going to plot the number of salads produced. So I'll label that here. So point A corresponds to 0 salads. That's down here. We'll label that as 0. And 500 burgers. This just means if Omnivoria chose to only make burgers, maybe it favors the carnivores this week, it can produce a maximum of 500 burgers if it devotes all its resources to producing burgers. At the other extreme, maybe Omnivoria is going to have vegetarian week. If it decides that it's only going to produce salads, it will produce 0 burgers, which is here on the y-axis, and that allows it to produce a maximum of 1,100 or 1,100 salads. So I'll label this point A, and I'll label this one point F. These are my two extremes. And again, this is just assuming that only one product or the other was produced. Now, one thing that we'll notice, and this gets back to the idea that the change is constant from point to point for burgers, but it differs from point to point for salads, is I can't just connect point A to point F and draw a straight line and be done. In fact, what we're going to see is because certain resources are better suited to producing salads or producing burgers, we're going to have a curved PPF, not a straight line. So why don't I work my way from A down to F and plot each of these points. So let's say if I reduce my burger production from 500 to 400, wow, that allows me to produce 600 salads. So I'm going to eyeball this, but as I said, ideally you'll be using graph paper, and your graph will be even neater than mine. Now let me continue at point C, 300 burgers and 800 salads. So that's going to correspond to roughly this point. At point D, 200 burgers and 950 salads. So there's 900, 1,000 right in the middle there. So we'll say 200. And at point E, 100 burgers, 1,050 salads. So this is right here, halfway between 1,000 and 1,100. And then finally, point F. Now, I'm going to try and draw a nice smooth curve to connect these points. All right, that's not too bad. We'll kind of go over here and pretend to make it a little bit neater. All right, so that's not as beautiful or as pretty as it would be if I were doing this on graph paper. But the key point is I don't have a straight line. So my PPF is nothing more than that curve, or we can think of it as the boundary. And in fact, it's a specific boundary when we think of production. It's the boundary between what's possible and impossible. So we'll just write that here. It's like a boundary. Inside and up to the curve, again, tells us the production combinations that are possible. Any point outside the PPF is impossible. Now we only have 6 specific points, but any point along this curve is a possible combination of burgers and salads. There's an infinite number of production possibilities. And in fact, as we just said, inside the curve is possible as well. The problem with being inside the curve is that we're not using all our resources or all our technology as efficiently as possible. What do I mean by that? Well, let's say I wanted to produce, or I found Omnivoria producing, I'll call this point X, 600 salads and 300 burgers. Now that point is possible, but Omnivoria could do better. It could continue to produce 600 salads, but increase its production of burgers, or it could hold steady at 300 burgers and increase its production of salads, or it could move what we sometimes say northeast and produce more of both foods, or both menu items. So what we see is if we're inside the frontier, we're not using our resources efficiently. Okay. On the other hand, maybe I'll label this point Z out here. Let's say 1,000 salads and 500 burgers. Z. So 1,000 salads. Okay, over to this side. Point C is impossible. Given the level of resources and technology, Omnivoria just can't produce that. Now, that doesn't mean it's hopeless for Omnivoria, that point Z will never be achievable, but that requires that Omnivoria either increase its level of resources, maybe it has a population explosion and it finds more workers when those children grow up and enter the workforce. Maybe they have a technological innovation that allows them to be more productive. Either an increase in resources or an increase in technology can shift the PPF outward, and that will allow the impossible to become possible. Now, on the other hand, if there's a loss of resources or a decrease in the level of technological innovation, a country like Omnivoria could see a contraction or a shift inward of its production possibilities frontier. We might see this in the wake of a natural disaster, like a hurricane or an earthquake that destroys infrastructure. We could even think of the current worldwide COVID-19 pandemic as an example of this, because it's keeping labor resources from being as productive as possible. Okay, a couple other things I want to point out about our production possibilities frontier, going back to this difference in terms of the interval or rates of change. Because this is not a straight line, it's showing me or indicating that the opportunity cost is changing. In fact, if I look at my table here, I can see when I give up the first 100 burgers, that allows Omnivoria to produce 600 salads. It goes from 0 salads all the way up to 600. That's a huge increase. One way to think about that is we can imagine that resources throughout a society are not equally suited to producing one good or another. We might have soil that's good for growing, and we might have land that's good for grazing. So that could be an example of natural resources that aren't equally suited to producing the ingredients for salads and the ingredients for burgers. We might imagine a greenhouse and a slaughterhouse having different needs. A greenhouse really needs some exposure to sunlight. A slaughterhouse is less sensitive to climate conditions. Or we may find that workers, in fact, have different skill sets. Someone who might be a whiz at mixing ingredients or being very detail-oriented in preparing a salad might be terrible at grilling. And the master of the grill might get a little clumsy or not find it as easy to produce a salad. So as we allocate resources across the production of these two products, we find that some are better suited to making salads, some are better suited to making burgers, and that's what would allow us to be on our PPF. Okay, a couple other things to just point out. One of the reasons I really love the PPF as a model, it illustrates not only some of our key concepts like trade-offs or opportunity costs, which we've discussed, what we see here, in order, again, to produce more salads, we have to give up some burgers, or if we want to produce more burgers, requires us to reduce our production of salads. So we see trade-offs and opportunity cost on the PPF. It also really reinforces the idea of scarcity for us, right? The frontier is the maximum we can produce given our resources and technology. We have limited resources. In order to produce beyond that and change that required trade-off, we have to acquire more resources or undergo some kind of technological innovation to get more from our resources. The PPF also does an excellent job of helping us to see the answers to some of those fundamental economic questions. What to produce would be answered by the specific point or combination of burgers and salads that we observe in Omnivoria. Hopefully Omnivoria is somewhere along this frontier, but as we've seen, they could be at a point like point X. That would indicate, again, that that's what they're producing, or the quantities of each good. How to produce, one of our other fundamental economic questions, is also answered by observing where on the PPF diagram, we see a society. If Omnivoria is at point X, we know they're not producing as efficiently as possible. Maybe they need to switch up their combinations of resources. They need to reorganize or reallocate workers or land or inputs or equipment to different types, from salads to burgers or vice versa. If instead Omnivoria is along this PPF, along this curve, then we know they are producing in the most efficient manner possible given their level of resources and technology. Now the for whom question is a little trickier because that's more of a normative question, but depending on where the combination is, does it tilt more toward burgers and toward fewer salads? Maybe in Omnivoria, carnivores or meat eaters have greater political power. If instead Omnivoria is more in this section of the PPF, the salad eaters or the vegetarians might be stronger or may have a stronger voice. So it starts to give us a little sense of what the society's values are. Okay, so I encourage you, I just should have said this at the beginning, there is going to be a handout that mimics this, and I encourage you to practice graphing and plotting these PPFs and making sense of how this model helps illustrate economic concepts like scarcity, opportunity cost, and the 3 fundamental questions. Great, see you next time.